Welcome to The Explainer. Today, we're going to break down how Docker is pretty much essential for taking your machine learning models from a personal project, something that just works on your laptop, to a real production-ready application that can run literally anywhere. Okay, so let's just dive right in. Picture this. You've spent weeks, maybe even months, training this brilliant machine learning model. It works perfectly. But now comes the hard part. How do you actually get it out into the world so it works for everyone, everywhere, every single time? If you've ever tried to deploy a model, you've probably slammed right into this wall of just frustrating errors. It's that classic, well, it works on my machine problem. The server has a different Python version, and boom, your code breaks. A library is just a tiny bit different, and everything crashes. It is a complete and total mess. Right, this chaos? This is what we call the deployment nightmare. And honestly, it's this exact set of problems that stops so many amazing models from ever seeing the light of day and actually making a real impact. But what if you could package up your entire project? I'm talking the model, the code, the exact Python version, all of its dependencies, and put it into a single, neat little box that just works everywhere. Well, that's exactly what Docker does. So the best way to think about a Docker container is like a universal shipping container, but for your software. It uses some really clever built-in features of the operating system to create this lightweight, totally isolated bubble around your application. So it doesn't matter if you send it to a server in the cloud, a coworker's computer, or some tiny device, whatever you put inside is guaranteed to run the exact same way. And what's so cool about this is how it directly maps each piece of that deployment nightmare to a specific Docker solution. Those Python conflicts? Gone, thanks to the isolated environment. That complex setup process? Nope, you build it once and then you can run it forever. Docker basically transforms all that risk into rock-solid reliability. So here's the crucial point, right? Docker takes these three critical pieces, your trained model, your application code, and the entire software environment it needs to run, and it fuses them all together. You get one single, portable, reproducible, and production-ready unit. Okay, this might seem a little complex, but I promise you it's not. Let's totally demystify the process of actually building one of these containers for your machine learning model. The heart of this whole thing is just a simple text file. It's called a Dockerfile, and really it's just a recipe, a step-by-step set of instructions. You start with a base, like a clean Python environment, you copy your files in, install whatever you need, and then you just tell it what command to run when it starts up. Simple as that. Now, once you have your Dockerfile recipe ready, you run this one simple command in your terminal. This tells Docker, hey, read my recipe and build an image. An image is like a frozen blueprint or a template for your application. It has everything it needs to run, all bundled up. And then, with a second command, you bring that blueprint to life. This command takes your image and runs it as a live, isolated container. So think of it this way. The image is the static blueprint, and the container is the actual running application created from that blueprint. And you can launch hundreds of identical containers from that one single image.
And bam, just like that, your model is running as a live API. You can open your browser, go to this address, and actually interact with it. It's all neatly packaged, completely isolated, and ready to be shipped anywhere in the world.
But, making it run on your own machine is just the beginning. The real magic happens when you realize that this little container you just built can now be deployed to the entire world. Because it's containerized, that single image is now portable enough to run on pretty much any major cloud platform you can think of, from AWS to Google Cloud, or even on tiny little edge devices like a Raspberry Pi. The setup is the same everywhere. That's the power of it. And this is just brilliant, especially for you folks working with heavy-duty models. If you're doing massive deep learning tasks that need serious hardware, Docker integrates with GPUs seamlessly. You just add a simple little flag to your run command, and your container gets all the processing power it needs. Okay, so now that you see the power here, let's cover some quick but really crucial tips to make sure your containerized deployments are as efficient, as small, and as secure as they can possibly be. Following these rules is absolutely critical for production. Like using a slim base image, that dramatically reduces your container's size, which makes it way faster to download and run. And a Docker ignore file is just as important. It stops you from accidentally packaging temporary files or sensitive secrets into your image. These aren't just suggestions. They're the little habits that make a huge difference in performance and security. And on the flip side, avoiding these common pitfalls can save you from hours of debugging failed deployments. A huge one is not pinning your library versions. If you don't, a new version could get pulled in months later and completely break your code. You've got to be specific, be secure, and be deliberate.
This quote right here, it just gets to the heart of the matter, doesn't it? The crucial point is that a model is only valuable when it can be used out in the real world. Docker is that bridge. It's what takes your work from a theoretical experiment to a real, impactful, and reliable application.
So learning to use Docker isn't just about solving a deployment problem you have today. It's about unlocking a more professional, more scalable, and more collaborative way of doing machine learning. It's really a foundational skill for modern MLOps. And that's it for this explainer. We'll leave you with this final thought. Those technical barriers that used to hold models back, they're gone. Thanks to containerization, the only question left is, what will you build?